coffee and a snack, we are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information. Grab a coffee and a snack, we are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information.
Attention span of a goldfish, and I've heard this many, many times. Is this something that younger generations are wearing as a badge of honor?
I don't know if they're wearing it as a badge of honor. And it's not just in social media. I think that we kind of look at there's great debate going on for kids. I have a mom of two young boys, and there's great debate on which shows are
Grab a coffee and a snack, we are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information. Grab a coffee and a snack, we are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information.
in channels like TikTok and Instagram and YouTube Shorts. We are also seeing a huge emphasis on long form content in YouTube. So if you feel like there's information that's a little bit more depth, a deep dive on
Grab a coffee and a snack, we are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information. Grab a coffee and a snack, we are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information. Grab a coffee and a snack, we are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information. Grab a coffee and a snack, the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information. Grab a coffee and a snack. We are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information. Grab a coffee and a snack. We are setting up. Grab a coffee and a snack. We are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR.
This is check, 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 check. So that's out of our board. That's not it? You can't hear me? Check, 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 check. All right.
Okay, we're ready to roll again, and a longtime favorite segment of our conference here since the get-go has been the first announcement to the world of the Colorado State University seasonal forecast for the hurricane season. Dr. Gray did it and then handed it off to his more than capable protege, Phil Klotzbach. So, Dr. Phil, our Dr. Phil, it is time to hear what you got for us this year.
Yes, sir. All right. Hello, everybody. I'm sorry. I do know how to format text. I'm not quite sure what happened there. I should have checked before. Hopefully, we don't have other fun text issues. So we're going to start with the numbers. Then I'll talk a little bit about kind of how we do seasonal hurricane forecasting. And I'll try to keep your attention for more than 15 seconds during this presentation. Sorry, it's more than one slide. I'm not going to do any TikTok dances or anything along those lines. So anyway, yeah, so the forecast for 2025 is for an above normal hurricane season. Not as active as we were forecasting last year at this time, though. A total of 17 named storms. Of those 17, 9 becoming hurricanes. Of those 9, 4 becoming major Category 3, 4, 5 hurricanes. Why we kind of separate out the majors is because even though they only make up about a quarter or 20 to 25% of all the storms, and in a year they do about 80 to 85% of the damage. We also forecast accumulated cyclone energy. That's an integrated hurricane wind energy metric that accounts for storm, basically longevity and intensity. If you're a baseball fan, it's kind of like the OPS of hurricanes. I'll be sure to throw in a few baseball references throughout this talk. My mentor, Dr. Bill Gray, who some of you had who some of you may have met a few times. I was a huge baseball fan. I'll mention Dr. Gray quite a bit throughout this presentation as well. A new metric we started forecasting a couple of years ago is the accumulated cyclone energy in the western half of the Atlantic Basin. Why we focus on that separately from the basin is because that's where people live, that's where property is, and obviously then you're getting more closely tied to impacts, which is what, if you were here yesterday and you heard Ryan talk, what he was focusing on some with his presentation yesterday. So when it comes to seasonal forecasting, though, a lot of people say this is how we do it. And actually, this cartoon, which was 2007, is perfect. See, verily, we see 17 named storms. So this is Dr. Gray, again, my mentor. That's not how we do these seasonal forecasting. I do tell I've told people that, my mom, when I was born, said, hey, look, this guy's going to be a meteorologist. He's going to be a forecaster, so we're going to name him Phil after the groundhog. That's not how we do our seasonal forecasts. We use a lot of weather and climate data and historical information to come up with these forecasts. We also now use a lot of model forecast data that today Dr. Gray wouldn't have had available to him when he started doing these forecasts back in the early 1980s. So this can be summarized in a couple of quotes from the legendary Yogi Berra. First of all, it is tough to make predictions, especially about the future. I think a few people have said that, and Ryan attributed it to Niels Bohr. So, forecasting the future is hard, right? Whether you're forecasting weather, whether you're forecasting sporting events, political races, all that stuff, it's hard. But we also find that you can see a lot by looking. Basically, by going back into the past, there are clues in the atmosphere-ocean system that can tip us off as to whether the current hurricane season is going to have above or below normal activity. There are these precursor signals. I'm going to try to convince you of that in this next plot. And here what we're looking at is June and July, so basically right prior to when the season really ramps up. In busy seasons minus quiet seasons. And this was the way Dr. Gray used to always say, if there's any signal, you basically take the top 10, difference the bottom 10, and if there's no signal, then basically it's just not really predictable. But there are kind of coherent spatial patterns in these sea surface temperatures. So in busier seasons, we tend to have a warmer tropical Atlantic. Makes sense, it's hurricanes live off of that warm ocean water. If we look in the tropical Pacific, we see cold water in the eastern and central part of the Pacific, warm water in the western Pacific. That's kind of your canonical La Nina-like pattern. And so Dr. Gray, when he was starting doing this research on seasonal hurricane prediction, he was teaching a tropical meteorology class, and this is long before the day and age of Wikipedia. This is back in the good old Encyclopedia Britannica days, but he knew which years were busy hurricane seasons. He knew which years had El Nino conditions, and he said, hey, when we have El Nino conditions in the eastern and central tropical Pacific, we tend to get fewer hurricanes in the Atlantic. And so the question then became, well, why would something going on in the Pacific Ocean impact hurricanes in the Atlantic Ocean thousands of miles away? So obviously, I'm sure most of you are very familiar with El Nino and La Nina. El Nino is warmer than normal water in the eastern and central tropical Pacific. La Nina basically colder than normal water in that same region. And why that matters is because of what it does to the thunderstorm activity across the Pacific Ocean. So in a La Nina, or kind of the average pattern, is that you get your strongest thunderstorms near Indonesia, where the waters in the Pacific Ocean are the warmest. In an El Nino, those water temperatures get warm farther to the east, so those thunderstorms shift farther east. And what you end up with is a change in basically the tropical circulation. So Dr. Gray used to always talk about this in, up, and out circulation in thunderstorm activity. So when you have deep convection, you have low-level winds converging into those thunderstorms. You get air going up in the thunderstorms, those towering cumulonimbus, and then high up you get upper-level divergence. So if we think about in an El Nino, you tend to get lower-level easterly wind anomalies, upper-level westerly wind anomalies. And if we think about the prevailing winds that we have in the Atlantic, typically those are your trades at low levels. Your upper levels are out of the west. So an El Nino tends to increase those levels of vertical wind shear. Vertical wind shear, good for us, bad for the hurricane. La Nina, basically the opposite effect. You tend to have much reduced lower levels of vertical wind shear, and overall tends to be more active hurricane seasons. And really with the seasonal forecast, while we're predicting the number of hurricanes, what we're actually really forecasting is a large-scale environment, not necessarily the individual storms. It's just with the large-scale environment is more conducive, you tend to get more tropical storms and hurricanes.
Grab a coffee and a snack. We are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information. Presentation. While you're enjoying that tasty snack, why don't grab a coffee and a snack. We are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information.
August. Dr. Gray, my mentor, used to ring a bell every year on August the 20th, signaling the active part of the hurricane season. And we still ring a bell every year in his honor. Now, last year, we rang the bell August 20th, and the hurricanes took about 4 weeks to respond. The end.
Grab a coffee and a snack. We are setting up the next amazing presentation.
Well, we're going to focus
While you're enjoying that tasty snack,
here in the eastern and
why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information.
waters there are a little bit colder than what we currently have.
Presentation.
If we look at what this
While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information.
So we're going to start by focusing in on the tropical Pacific, so it's in the cold water.
Grab a coffee and a snack. We are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live
So this big really pronounced pattern in trade winds. So the low-level winds are a big driver of sea surface temperature changes across the globe. So if we look in the central tropical Pacific, which is basically right here in the middle of this Hallmark plot, which are the best kinds of plots, lots of very strong winds, vibration, keeping the waters cool. But if we look farther to the east, we generally have
grab a coffee coffee and a snack, we are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information. Grab a coffee and a snack. We are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code.
Best chance is for and some neutral conditions for the peak of the hurricane season between August and October. Then we'd say probably, if that doesn't verify, more likely La Nina than El Nino, just given the pronounced trade winds that we do have across the tropical Pacific. If you like models and you love acronyms, here's a whole pile of acronyms. Bonus points to anybody who can identify what all of these acronyms are. I certainly cannot. But if you look, the black arrow denotes August to October, and almost all of the models are slightly bigger.
Grab a coffee and a snack. We are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information. Grab a coffee and a snack. We are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast?
One of the challenges we do have is El Nino has this phenomenon known as the springtime predictability barrier, which is awesome because we're trying to forecast hurricanes, and guess what? It's the spring. And so that does provide an extra challenge because if you're going to get transitions, this is the time of year that it tends to transition. So small changes in winds can make big differences in how
Grab a coffee and a snack. We are setting up the next amazing presentation.
So right now, we generally
While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information. Grab a coffee and a snack. We are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information. snack? Why don't you sign up for our live stream show and podcast? Grab a coffee and a snack. We are setting up the next amazing presentation. While you're enjoying that tasty snack, why don't you sign up for our live stream show and podcast? Just scan the QR code for conference information.
You want El Nino or not. And it is actually forecasting through September, actually a little bit below normal activity, but you have to realize if you look at the historical scale of the European Center model from their March outlooks, it's not very good. They've really kind of struggled with that. So we actually do incorporate some of the European Center and some of the statistical dynamical modeling, which I'll talk about here in a few minutes. Overall, the model is calling for actually a little bit drier than normal tropical Atlantic. Again, I'll be curious to see kind of how this looks when we get to the April outlook that they'll be putting out in a couple of days. So, when we come up with these forecasts, there are a lot of different tools that we use. So we use a statistical model, which is purely based on historical data. So this forecast comes out early April, so it's using data through March, because that's as far as we've got data right now. And so this basically what we do is we look for regions that worked well at forecasting activity up through March. So these are three predictors that in combination can explain a considerable amount of the variability in accumulated cyclone energy. That's the metric that we're trying to forecast. And then all the other numbers that you see on our seasonal forecast are derived from that accumulated cyclone energy value. So we use these three predictors in combination, and it can explain a reasonable amount of variability. You see correlation of 0.67, so you get about half the variance. But obviously, if you look, the blue line and red line are not perfect. And holy cow, the statistical model went through the roof last year. And that's one of the challenges with the statistical model, right? It's built on past data. So if you have a year like last year where sea surface temperatures in March were way, way higher than we had observed in any historical year, it can tend to blow up some stuff. So that's one of the challenges with when you're building a model on past data is if you have something you haven't seen before, the model may struggle somewhat. And obviously last year was a hyperactive season, very impactful, but very, very strange. And hopefully we have enough time to talk a little bit about that towards the end of this presentation. I want to talk a little bit about impacts. And so here we're looking at the hindcast because obviously the model that we're using now hopefully is going to work a lot better than, say, the model we were using in the 1990s. And so here we're looking at is the number of U.S. landfalling hurricanes compared with our hindcast of ACE since 1979. And if you look, there is a positive relationship, but it's a pretty big scatter, right? I mean, there's some years where the model was pretty aggressive for ACE and we didn't get many landfalls, or vice versa. And even if you were to say do observed ACE, as Ryan showed yesterday, there's skill there, but it's not massive because obviously a lot of storms in the basin, it matters how those storms are steered, where they form, all that stuff, and so you start to degrade your correlations when you do that. But another thing I wanted to draw your attention to was if you look at the 10 years where these hindcasts called for the least activity versus the 10 years where they called for the most activity, and you look at the overall damage, there is a pretty substantial difference. And so on a seasonal forecast time scale, we always emphasize you need to be prepared the same for every hurricane season because it just takes one. But we also know that in general, busier seasons are going to have more landfalls. Not a guarantee, but in general, they are going to have more landfalls just because there's more storms out there. And obviously, especially if you have a year like last year where stuff forms in the Western Atlantic, probably somebody's not going to be very happy, whether it's the U.S., Caribbean, Central America. So if we look at the damage and we look at kind of this box and whisker plot, you do see a pretty substantial difference in those. So just take that in mind when you're thinking about these seasonal forecasts. So our final forecast is pretty close to our statistical model, really pretty much almost the same, so not much of a difference there. So something else that we've started doing a few years ago now is a statistical dynamical model. So it's basically, you can consider it like a hybrid model, which is what I'll call it from here on, because otherwise it's too many words. So the hybrid model, what we do is we take forecasts from various modeling centers, so like the European Center, the Japan Meteorological Agency, the UK Met Office, and what we do is say, okay, these models go out at least through August, so forecast sea surface temperatures in August in the Atlantic, in the Pacific. So obviously, if you're looking for a busy season, the Atlantic should be warm, the Pacific should be cold. And then what we do is these models have what we call, also have hindcasts because we want to be able to calibrate and see how well the models did on the past. So the European Center actually has a hindcast going back all the way to 1981, which is awesome. The other three models, unfortunately, their hindcast period is 1993 to 2016. So if you're wondering why those years, it's because that's the data that they've made available. And what we can do is, since we have all this past data, we can see how good are these models at forecasting the Atlantic and the Pacific, and then assuming those forecasts are correct, how much storm activity would you expect? So for example, this, unfortunately, the European Center data that they have plotted on their website is 3-month averages, but August obviously is in the middle of that. So basically what we're looking at here are these two regions. So the tropical Pacific, a little bit warmer than normal, but the Atlantic still overall, that box, pretty toasty. So you can see, again, statistical model, statistical dynamical model, pretty comparable levels of skill, but it kind of gives us somewhat of an independent view, right? Because instead of looking just backwards, you're also looking forwards. And this really came in handy, especially in a year like 2023. So 2023 comes along, and we have a very likely strong El Nino, which we saw, and a record warm Atlantic. I was like, oh crap, how do we deal with this? This is something we hadn't seen in the historical record, because obviously you hadn't had a record warm Atlantic until you had that record. And so the prevailing wisdom was, in general, a strong El Nino dominates over anything else, so it should be a quieter season. But when we look at some of these dynamical models that forecast that, they said yes, but the shear in the Atlantic should be relatively low, which it was. And so we went with a busier hurricane seasonal forecast, which actually verified pretty well. So having these kind of numerical dynamical models is a really big asset, especially if we have these kind of situations where we're kind of off the grid in terms of what we've seen in the historical record. Now 2025 looks to be much more in line with what we've seen historically. You're probably going to come up with somewhat different years because we're maybe looking at a little bit different stuff. So we selected 6 analog years. These years were selected based on they were the second year following a strong following an El Nino. So we wanted years that had El Nino, say 2 years prior, so 2023 into 2024. So this is the second hurricane season after the El Nino. And then also generally had a relatively warm Atlantic. And so when we select these analog years, what we're looking at isn't necessarily obviously not looking necessarily at tracks, it's just overall these conditions are fairly similar. And typically with April, there's a fairly large spread. Last year, pretty much all the analog years were gangbusters, but this year, there's a fairly large spread. So we have 1996, 1999, 2006, 2008, 2011, and 2017. And if we think about ENSO, 99 was a pretty healthy La Nina. 2006, we went right back to El Nino again. So it can change a fair amount. And again, we're not forecasting tracks based on these, because obviously if you're looking at things like impacts, some years had almost no impacts, and obviously 2017 was obviously a very impactful season. So just kind of highlighting the uncertainty associated with these outlooks. And if you're like uncertainty, we also calculate probabilities of exceedance, similar to what Ryan showed yesterday with his stuff. We calculate probabilities of exceedance because when we do our seasonal forecast, we give you kind of our best estimate, but we also know there is obviously uncertainty associated with these forecasts. And especially in April, the uncertainty is fairly large. There's a lot that still can change. We're still basically 4 months prior to when stuff really ramps up. So if we look at probabilities of exceedance in April, it's a pretty big spread. And that's, again, there's just a lot of uncertainty at this lead time. The spread is lower than if you were to say forecast climatology spread, but there's still quite a bit of spread. And if we look at our confidence intervals for these various metrics, the spread is, hurricanes, it's 7 to 12 when you forecast 9. And so these aren't necessarily going to be perfectly symmetric around the mean just based on the historical errors. But overall, you do see a fairly big spread. This is very similar to what you would see, say, with a seasonal hurricane forecast from NOAA, where they provide the range of numbers. And we use a 70% range, which, again, is very similar to what NOAA does. We like to give the best number, or our best estimate number, just because when it comes to getting conveyed, oftentimes, if you say 7 to 12, someone in the media will say up to 12, which then basically everything gets viewed as the high end of your range, which is what we're not forecasting. So at least this way, we obviously are very aware that these forecasts are highly uncertain, so we do provide that information. As I mentioned before, we do forecast ACE in the western half of the Atlantic Basin, and the reason we do that is because obviously, that is the ACE that really matters. Obviously, the east of 60 matters for shipping, but thus, if it just stays east of the land masses, that's not necessarily that big of a deal. Obviously, the western half of the basin, it's a really big deal. And so there's a variety of different things we can do, but here we're forecasting ACE in the western half of the basin, and that's basically like angst ACE because that's more directly tied to landfalls and impacts both in the U.S. as well as the Caribbean and Central America. Now these percentage differences aren't huge, but in general you see more of the ACE that forms in the basin in the western half of the basin in La Nina relative to El Nino. Two reasons for that. One, La Nina tends to favor formations in the western half of the basin. El Nino, you really tend to ramp up your shear in the Caribbean. And also, storms tend to be a little more likely to recurve in El Nino years. And the last 2 years, I think, are a good example. 2023 was a busy season, but a lot of the storms formed pretty far to the east. A lot of storms recurved. And from an impacts perspective, not super high. ACE was a little less than 50%, or percentage of basin-wide ACE was a little under 50%. Last year, a lot more of the ACE in the western half of the basin. It was north of 60%. So again, not huge differences, but this is getting a little bit closer to what we can forecast in terms of impacts. And so again, basin-wide ACE, this is looking at North Atlantic landfall. So any making landfall anywhere in the North Atlantic, not saying just the US, correlation's 0.66. If we look at the same with ACE west of 60, correlation's up to about 0.8. So again, this is getting more towards impacts. Obviously, we can never say in April or heck in August, a storm's gonna make landfall at this exact point, but this is getting more towards impact-relevant metrics. We do provide probabilities of landfall, and this is based on historical data and then adjusted based on our ACE west of 60 relative to what is ACE west of 60 relative to the average ACE west of 60. And you can see the probabilities for 2025 are elevated. We also provide probabilities of impacts. And so here we're looking at is storms that track within 50 miles of each county, parish, state, country, all pretty much anywhere along the U.S., Canada, Central America, Caribbean. And so the reason that we do this is because a storm doesn't have to make landfall in your county to have significant impacts. Obviously, if a storm's tracking within 50 miles of your county, it's probably not a great day. So we basically just drew a radius around each county, counted the number of storms. In this case, we're looking at data from 1880 to 2020. So you calculate the number of storms. For example, this is Plymouth County, where I grew up. We had 10 hurricanes within 50 miles of Plymouth County between the 1880 and 2020. And then you can convert those to probabilities and come up with basically the odds of one or more storms tracking within 50 miles of each county or parish. And then what we do is we adjust those probabilities based upon our latest forecast. Again, these probabilities are somewhat elevated this year, given overall the seasonal forecast is for an above normal overall hurricane season. So this is just an example. We obviously have every state from Texas to Maine, but obviously, for example, look at Texas. On average, it's a little over 1 in 3 chance that a hurricane tracks within 50 miles of Texas. This year it's a little bit higher at 44%. So again, we do update these forecasts. The initial forecast came out today. Another update will come out on the 11th of June, another update on the 9th of July, and a final update on the 6th of August. Once we get to the 6th of August, we will also be putting out 2-week forecasts, which try to kind of more going from say like, okay, the season looks busy to how are the next 2 weeks going to look? And then you can start to go more from basin-wide stuff to actually talking more about specific regions that may be impacted and things like that, so that you can get a lot more towards potential areas that could be impacted. If you like seasonal forecasts but don't want to take in a bunch of different ones, I invite you to check out seasonalhurricanepredictions.org. Right now, the website only has a few contributions on it, but we'll be getting a whole lot more here in the next month or two. So this is a collaborative effort between our group at CSU, along with the Barcelona Supercomputing Center, with some funding from AXA-XL, and you can see all these different groups that contribute to this website. So they include private sector weather companies, government agencies, universities. More universities contribute from landlocked states than do from states that actually border an ocean. So take that as you will. So this is an example of what it looked like last year. So all the different groups are color-coded. So purples are private weather companies, blues are government agencies, greens are universities. The orange dot on the y-axis is the average of all of the forecasts. So last year, the average of all of the forecasts was for 11 hurricanes. We got 11 hurricanes. The red dot represents the observed value to date. We screenshotted this in the middle part of August. At that point, we had 3 hurricanes. So I invite you to check out this website. I will put on CSU's forecast on the website when I'm done with this presentation. So it's not on there yet. And so with that, I've tried maybe, let's see, it is 9:35. I've got maybe to take a couple of questions, and I did want to talk a little bit about last year, because I think there might be some questions on that as well. So we'll leave this side loop of barrel up there while, if maybe we'll do 2 questions now. I don't know, we're going to pass the mic around, or I see Hal has a question in the back. The golf tends to be a real can of worms in terms of, having much in terms of the way of predictability, in terms of on a seasonal time scale. And I think a lot of that is due to mechanisms. So the Gulf, you can get storms that come all the way from Africa, go all the way across, end up in the Gulf. Or they can be storms that, say, form in the Caribbean, like we saw last year with Helene. So last year we kind of had everything, right? Because we had all those landfalls in the Gulf, but we had like a barrel, which came pretty much, easterly wave came off of Africa. Then we had a storm like Helene, which formed from this broad Central American gyre. And then you also had Francine, which mostly came from a wave, but didn't really get going until it got into the Bay of Campeche. So I think it's hard to say a whole lot about the Gulf, unfortunately. It tends to be a region with fairly low seasonal predictability. It has good predictability on shorter time scales, but seasonally, while obviously it's a hugely impactful region, unfortunately it's a pernicious region to forecast. Yeah.
Hi, Philip.
Hey.
Quick question. How do you factor in the African dust situation the last few years and the aerosol effect from that? Because that's something, as a hurricane chaser, I'm always watching, because it can really kind of nuke at least the beginning of the season.
Yeah, and so I'm actually going to talk somewhat more about that as we talk about last year, because it was quite interesting how things worked last year. So I'll briefly tease it now. So last year, historically, if you look at like average dust versus shear sea surface temperatures, generally we have a lot of dust. It tends to be associated with more shear, stronger trades, and colder waters. Last year we had very low shear, very warm waters, and a lot of dust. And so at the time, we kind of discounted that, because it was like, okay, this thing's kind of weird and going opposite. But when you get a lot of dust, that can actually excite the northerly track for African easterly waves, which I think is one of the reasons why they shifted so far north when we got to the middle to later part of August. So if we look, for example, late August, some of the National Hurricane Center, their Marine Division, when they're monitoring the African easterly waves, there was only one in the entire Atlantic. Like, there was just no seeds for anything to form on. So those definitely something we're going to be looking at. There's not a lot we can say about it now, but once you get into June and July, that's when you start seeing the dust. And so dust is a little wonky, because when you get a robust African easterly wave, it'll bring dust out behind it. So just because there's dust, one of the biggest dust outbreaks on record was in late June of 2020, and obviously we know 2020 was a pretty dang busy season. But the consistent dust that we saw last year, I think, was kind of a warning sign that things weren't quite as conducive as otherwise seemed to be. So let me just dive into 2024 a little bit, and then I'll take any other questions that we have on either 2024 or 2025. And so obviously 2024, a busy hurricane season, hyperactive, but got at it at a very strange way. Obviously, when I came and talked last year, we said very, very confident of a highly above normal season, given just the plot of sea surface temperatures. It was really, really hot out there. And we had the earliest Category 5 on record in Hurricane Beryl. It seemed like things were really, really off to the races. And then we had Debbie, we had Ernesto early to mid-August. We were looking like things were really gangbusters, and about mid-August, stuff just started to look kind of weird. And I'll talk a little bit about that here in just a minute. The National Hurricane Center just finished their final tropical cyclone report. They just finished their report on Milton. Both Milton and Helene, and frankly, all the reports are excellent reads. So I invite you to check those out. But overall, the season did end up just got into the hyperactive category. You need to get an ACE of, I think, 159.6, and we got 162. So we did make the hyperactive threshold, which I certainly did not think was going to be the case in mid-September. Obviously, the tracks of 2024, you don't see a lot in the Eastern Atlantic, which I think was a bit of a surprise. But unfortunately, a lot of tracks in the Western Atlantic, and obviously a very impactful year. Caribbean, obviously, Beryl does a lot of damage in places like Grenada, St. Vincent, and the Grenadines. And then obviously, for Cuba, both Rafael and Oscar caused a lot of flooding and wind damage. And then obviously the U.S. with those 5 landfalling hurricanes, and obviously the 2 most damaging ones being Helene and Milton, but obviously all 5 of them causing pretty significant damage. If we looked at August through October of last year, we had a officially cool neutral tropical Pacific, and a very warm Atlantic. It would have been the warmest Atlantic on record except for 2023, second warmest on record. And if we look at the temperatures in this box versus the rest of the global tropics, it was cold. And so NOAA officially uses an index which is just this box, but they also are now using another index called basically a relative oceanic Nino index, which is effectively temperatures here minus the rest of the global tropics, which gets more at the air, where the air is going up and where the air is going down across the tropics, which is a big driver of your vertical wind shear. And so that was cold. So that's something we're using more, and I think NOAA's talking about quite a bit more as well in recent weeks or recent months. Vertical wind shear last August through October, lowest on record, all the way back to 1950. So we had lowest shear on record, record warm SSTs. So you would have thought the season would be, pushing 2005 kind of levels, but it didn't. But it is interesting. If you look at the plot between wind shear in August through October versus this accumulated cyclone energy during those same 3 months, August through October, see, it's a pretty good relationship. I mean, you can play around with fitting different things, but a linear, just a straight up linear line fits the relationship fairly well. But we look at 2024, the shear's lowest on record, and basically for that, it underperformed. And so when this relationship between shear and ACE is off this scatter plot line, those are often the years where our seasonal forecast does not verify as well. Last year's seasonal forecast is a kind of a challenging one to verify because some of the numbers, like the number of hurricanes and majors, verified almost on the nose or on the nose, depending on which time. But the ACE was quite a bit lower, and that's because we had the intensity, but we didn't have a duration. Most of the storms that formed in the Western Atlantic, so we just didn't have the long track. So we got a lot of we got the storms and we got the intensity, but not the duration component that you need to really drive up that ACE quantity. I'm not quite sure why this, I did not format it this way. I apologize for this. But overall, yeah, we're going to keep the July forecast at bay. No one wants to see that one. We're going to keep that in stealth mode. But overall, the seasonal forecast verified pretty well for hurricanes and major hurricanes. Again, ACE was too high, as well as number of storms. We didn't get a lot of weak, short-lived storms last year. The storms that formed, unfortunately, in general, were fairly gnarly. But it was a very wonky season. So this is accumulated cyclone energy. So 2024 is the red line. The blue line is average. And you can see kind of the normal average climatological bump up mid to late August. You see the huge spike in 2024 in July from Beryl. And then basically when the season normally bumps up, it went in the toilet until you got to late September. And then, holy cow, there's a huge spike. And so it basically tried to make up for lost time. But I want to talk a little bit about this lull because certainly, everybody thought after Beryl and everybody's seasonal forecasts through the roof. Everybody thought this season's going to be one for the record books, and then the season just completely fell apart in terms of activity. And there were a lot of media, talked to a lot of reporters. What the heck is going on? Scientists were puzzled. I spent my Labor Day writing like a 20-page paper trying to explain what the heck happened. I'm happy to report that we are turning this 20-page paper into a more formal journal article publication. Hopefully we're going to be submitting this in the next couple of weeks. So we're going to try to really kind of quantitatively look at some of the drivers. And then, of course, the big question, the million-dollar question is, can we forecast this? Because that's obviously the key, is can we forecast when you have these kinds of strange things happening. But there really hasn't been a season like 2024 that was hyperactive, that went completely quiet during the middle of the season. That was really, really unusual. And so there are a variety of different factors, I think, that came into play. One is the African easterly wave shifted really far to the north, and especially during the middle to later part of August. And so one of the things that happened, so when reporters start calling and asking questions, we said the easterly waves were too far north, and so that kind of became the answer that you saw in the media a lot for the whole time. And I think it was a big driver during mid to late August. But then those easterly waves did tend to shift back towards more normal latitudes, and the season was still very quiet. So it wasn't the whole reason why it broke. And so normally, when you have a very warm tropical Atlantic, that intertropical convergence zone and where those African easterly waves come off Africa will shift a bit further north along with the warmest waters, but they went way farther north, and I think some of that was probably due to the enhanced dust, because that can tend to basically excite the northerly track of these African easterly waves. And instead of coming off at more latitudes of places like Senegal, it was northern Mauritania, western Sahara. You think Sahara, you think dust, dry air, and the waters off of Africa, as you move further north, cool very, very quickly. So these storms basically didn't have much of a chance. One of the things that we looked at is potential intensity. So potential intensity is kind of a measure of juiciness of the atmosphere. So that's a function of both sea surface temperatures, but also temperatures aloft. So temperatures in the ocean surface were quite warm, but higher up in the atmosphere, they were also very, very warm. A lot of that due to the previous El Nino that we had. El Nino tends to warm the upper troposphere due to changes in basically global convection. So we had a very warm upper atmosphere, and warmer upper atmosphere tends to stabilize the atmosphere and basically knock down some of that juiciness. So if we look at the subtropical eastern Atlantic, the potential intensity was pretty pronounced, or pretty markedly reduced. So they were coming off at higher latitudes where the conditions generally aren't that optimal, and last year they were even less optimal, even than in an average season. We also, during kind of the peak of the season, we had this anomalous high pressure that developed just east of Newfoundland, and we think about a high pressure system, the circulation around that's going to be clockwise. So you're bringing in dry air down from the middle latitudes into the tropics during the peak of the season. So we had this kind of going on as well. So I think this, in combination with hurricane unfavorable phases of the Madden-Julian oscillation. So the Madden-Julian oscillation is named after two dudes, Madden and Julian. Obviously, if you get an oscillation named after you, you're good to go. All your grants get funded. And so these two guys basically discovered an oscillation that is associated with tropically propagating convection about every 30 to 70 days. Sometimes it's strong, sometimes it's weak. So it's not always a great predictor. Last year it was very robust. So we had these pronounced periods of tropical convection where and if you're looking for storms in the Atlantic, where the conditions are most conducive is when it's for Africa and the Indian Ocean, because you get upward motion in over there, which tends to kind of enhance your easterly waves. But also, lagging that convection, you get anomalous low-level westerlies, anomalous upper-level easterlies, which counteracts your prevailing vertical wind shear. Alternatively, when it's over the Pacific Ocean, that tends to be more sinking motion, dry air, and a lot more more shear. So even though the shear was very, very low, during the peak of the season, we had a couple of bouts of higher shear. We had a couple of what we call these tropical upper tropospheric troughs, which are the bane of hurricanes' existence. They cause a lot of upper-level westerly wind shear. And we saw that most notably with Francine. Francine, basically there have been almost no tuts all year. Basically, the wave was coming along and a tut dropped just as Francine got there. Otherwise, Francine probably would have been a hurricane several days earlier. So this also kind of knocks stuff down. So this is one of these plots showing this Madden-Julian oscillation in real time. So phases 4 to 7 tend to be bad for hurricanes, good for us. And so basically it was bad for hurricanes over most of kind of that climatological peak of the season. But we know the MJO propagates eastward with time, so it's moving out on September 22nd. It's kind of moving out of those bad phases for hurricanes and moving into more conducive conditions. And we had very pronounced upward motion, and all of a sudden all hell broke loose, starting obviously with Helene. Upper level temperatures also anomalously cooled, so we had a much more unstable environment. So you could kind of see all the different things that were holding the season back all broke at about the same time. Then we went to setting records the other direction. 3 hurricanes in October simultaneously. We had Milton, we had up at the far northern latitudes, and then we had Leslie in the deep tropics. And we set records for the most hurricane activity on record between September 24th and October 11th, and the most accumulated cyclone energy as well. I'm sorry again for the font corrections. I'm not quite sure what happened there. Obviously, Hurricane Helene, we've already talked a lot about that. One of the things I wanted to emphasize with Helene is it formed from one of what we call these broad Central American gyres, which are these broad areas of low pressure. So it had it formed from a very large circulation, so it was big from its inception, and obviously bigger hurricanes, all else being equal, obviously going to have a larger area of wind, a larger area of rain, and unfortunately also a very large area of storm surge. And obviously we saw Helene's storm surge was massive, all the way from the Big Bend all the way down south of Fort Myers. You can see that Helene was a very healthy storm when it came on shore, rapidly intensifying almost up to the point of landfall, very pronounced, and also just very, very large storm. 175 direct fatalities from Helene, 79 billion in damage. There was a very large insurance protection gap with the storm because so much of the damage was surge and flood. And I'll show you in just a minute how unfortunately a lot of the area that was flooded, very low insurance NFIP take-up rate, a whopping 16-foot storm surge, and obviously a tremendous amount of inland rainfall as well. I don't have time to go into all the details of the pre-event, which was really one of the big drivers of Helene's rainfall. And then also, Helene took that very kind of strange northwest bend after it came on shore, and that basically, the counterclockwise circulation around that low pressure, all that air went up over the Appalachians and rained out, and that was really kind of the straw that broke the camel's back and caused what would have been bad flooding and made it cataclysmic. If we look at the national flood insurance take-up rate, in most of the areas that had the worst of the flooding, you can see either gray or blue, so very low levels of NFIP take-up. Then we had Milton. The best track report on Milton came out just a few days ago. It's a really, really good read. I definitely recommend checking it out. Milton hit the ground running from a tropical storm to a Category 5 hurricane in just 2 days. Pressure below 900 millibars. That's really impressive. It's the lowest pressure in an Atlantic hurricane all the way since Wilma back in 2005. So this is Milton at its max intensity. It was really, really amped up at this point. A very tight circulation. And so you look at Milton and you see the Yucatan Peninsula, and it's like, had this storm been 50 miles farther south, it goes over the Yucatan and probably isn't much of a problem for the U.S. But it's just north of the Yucatan and obviously was a big problem for the U.S. If we look at Milton as it's coming on shore, though, it really did fall apart. Very strong westerly wind shear, which obviously weakened the storm, which is great, but that same strong upper-level westerlies, which were bad for the hurricane or good for tornadoes, and obviously saw a lot of tornadoes due to both the fact that it had a lot of very strong westerly winds aloft, so very strong shear, but also the storm making landfall in the evening hours. There have been a lot of daytime heating on the east coast of Florida, so the atmosphere was very juicy. So if you have a highly unstable atmosphere and a lot of shear, that is usually a good recipe for significant tornadoes. And we had 3 EF3 tornadoes with Milton. I believe the most in any other storm was 1 back, and they've been doing hurricane spawn tornadoes database goes back to 1995. Obviously, a much lower insurance protection gap with Milton because more of the damage was wind. Over 18 inches of rain in St. Petersburg, a 10-foot storm surge, and also just an extremely rapid intensifying storm, the max rate since Felix all the way back in 2007. And so that's what I have on that. I always like to finish my presentations with a quote from Arago, who is the head of the Paris Observatory. And I think certainly in this group, everyone here would agree, never, no matter what may be the progress of science, will honest scientific men or women who have regard for the scientific men venture to predict the weather. So thank you.
If you have questions, we have a mic up here toward the front. Please come up to the front and use the microphone for your questions.
Check. Okay. One question I have, you talked about all the different blended models. Do you derive anything from the GFS or the Jeff's model at all that helps you?
So on a seasonal timescale, so like the climate forecast system, unfortunately, is not one of the better performing models.
That's
so.
I was curious.
Yes, yeah. So and these various dynamical models all have they're different, but if you looked at kind of the spread of those different models at the various hindcasts, there wasn't a ton of spread. So incorporating more probably won't help a ton. The European Center model will be coming out with a new version of their seasonal model. I believe it's targeted for November. So I'll be very interested to see kind of what that shows. I believe they're actually going to have even a longer hindcast period, which will be really good too, because I'd love to get back into some of those, into like the 60s and 70s and see how well it does there. Because the more years of data that we have, the better for us. And so that's something we're going to be looking at. And the other models are always undergoing upgrades as well. So I think with time, hopefully those statistical dynamical models will continue to give us, better levels of skill. Yeah.
Hi, Cheryl Nelson, Norfolk, Virginia. What are your thoughts about stronger tropical cyclones making it to more northern latitudes this season? I know we're seeing more of that in recent history. What are your thoughts for this season?
Yeah, so when we look at like lifetime maximum intensities and where storms are, a lot A lot of it is related to where the storm forms. So if a storm forms at really low latitudes, it tends to get strong at low latitudes and then weaken as it goes farther poleward. So when we're looking at if you look at so a lot of the research that's been done talking about storms kind of shifting poleward has been focused on the western North Pacific, where it's a pretty pronounced northward shift. Some of that is likely due to this kind of long-term trend towards La Nina. La Nina tends to shift where storms form in the western North Pacific further poleward. In the Atlantic, it's almost basically the opposite. We tend to get more deep tropical storm formations in La Nina events. And so overall, yeah, we haven't seen a ton of that signal in the Atlantic. It's been more of a Pacific signal. The Atlantic tends to go opposite of the rest of the globe, and we see that even northern hemisphere wise. If you look at the global number of hurricane strength storms, it's actually significantly downward since 1990, and that's because the Atlantic's going up, but the Atlantic does not drive the global hurricane typhoon bus. It is a pretty small player, and the Pacific in a La Nina tends to get throttled. So if you go and ask colleagues that live in places like Japan and China, they're saying, where the heck are our typhoons? The trend is way down there. And so there's a lot of kind of these things that we're still disentangling, which are really fundamental for when we're talking about, what is the future of hurricanes, typhoons, what's the future of global storms going to look like? As long as this trend towards more La Nina-like basic state continues, the Atlantic is probably going to, from a hurricane perspective, win, while the Pacific will probably continue to be quieter. And so that's a big question that's being discussed a lot, because climate models pretty much all say a more El Nino-like future, and the real world says we're going the opposite direction. And so there's a lot of discussion, a lot of debate as to, is this a temporary thing, is this a long-term thing, and how temporary is temporary? If it goes another 30 to 50 years, that's probably what most of us care about. So there's a lot of these kind of questions that we're still trying to iron out.
Hey, Phil, great
Hey,
talk. I know there's been some really interesting work done at CSU recently anticipating some of those dry air incursions into the deep tropics in the peak of the season. So I was just wondering if you could talk a little bit about your expectations for the wave breaking parameter for the season ahead.
Well, thank you very much for teeing that up. So we actually do have one of our predictors in our April forecast, basically looks at upper level winds in more of the subtropics. And so that predictor actually is saying we may see a fair amount of wave breaking in 2025. And that when you get, basically wave breaking is effectively when you get kind of these dry air, which when you get your big dry air intrusions into the tropics and you get a lot more shear. Last year we had very little wave breaking, which is one of the reasons why we had very low shear overall. But those, when you get what we call these upper level lows, cold lows into the tropics, that can be kind of, can shut down stuff for anywhere from 3 days to as much as a week, even longer, just depending on how kind of pernicious it is. In 2022, we saw that for us basically the entire month of August. Like cold low after cold low, we had diddly squat in August. No storms in August. And then obviously we got to September, and basically Earl helped kind of push that mess out, and then suddenly the season woke up. So the cold lows is something that's a little more challenging to forecast, because we can predict the tropics fairly well, but the mid-latitude tropical interactions is still a challenging problem. That's probably some of that unexplained variance that we all have in our seasonal forecast. But yeah, we are trying to work more and more on that. I think especially on the sub-seasonal time scale, you can start to forecast these things a couple weeks out.
Dr. Phil, thank you for your presentation. My name is Rodney Chai. I'm the Science and Operations Officer at National Weather Service, Brownsville. Started my career in Taunton, Mass., so very close to where I grew up. So I have a question here. So, maybe this we can hope, I've been thinking a lot about since Francine devastated North Carolina, western North Carolina with the cataclysmic flooding. So I, kind of like a brief memory jog back to the coverage of Francine. I mean, there was a lot of media attention surrounding the intensity and the landfall of Francine. I know that WPC put out, moderate to high risk of excessive rainfall. I mean, it was the flash flooding to meteorologists. I mean, we know it's going to be catastrophic flash flooding in the Appalachians. So it's heartbreaking to still see the devastation, and so many of the communities in the Appalachian are still struggling to recover. So I'm just wondering, given your professional expertise, there's a lot of focus on the ACE, accumulated cyclone energy. Obviously, people are, just because of how hurricanes are categorized, people are focused on the peak intensity, the eye wall, and the rapid intensification. But a lot of times, it's just like, give you an analogy, like severe weather, right? People are focused on tornadoes, the 80-mile-per-hour wind. But then, when you have the severe weather system, the hydrology is often, and I'm not going to say it's an afterthought, but it's kind of like not as emphasized as much, at least in the public's, mindset. So just given your expertise, your experience, with global warming, climate change, a lot of these systems are going to be, create a lot more flooding issues. So what do you and just thinking out loud, maybe we can have kind of something similar to ACE, but focus more on the moisture transport. What are your thoughts? So just thinking out loud. So thank you very much.
Yeah, we've been working a lot on using pressure to categorize hurricanes because pressure's not going to get a ton at the flooding, but pressure will get a lot more at the size of the storm than, say, just the maximum sustained wind. So if you have a very low pressure, but the winds aren't super strong, that means your storm is enormous. And Katrina is a great example, right? Like, Katrina was a Category 3 by wind, but it had a pressure of 920 millibars. The storm was enormous and had a 29-foot storm surge. And so larger storms are going to have an overall larger areal extent of rain. Obviously, in the case of a storm, it's on a seasonal timescale. I don't know how much we can do on the flood component because so much of that is either the translation speed of the storm, or in the case of Helene, it's like a pre-event, and that, they can't forecast that on a seasonal timescale. So I think really the flooding needs to be kind of forecast separately. So, whether you use a wind, whether you use pressure to categorize kind of the intensity of the storm, the rain just needs to be separate because from a scale perspective, we don't want to say, a storm like Imelda's a Category 5 because it's going to bring a ton of rain because people get really confused. But if you can say, yes, the storm itself, the wind impacts are likely to be very small, but it's going to bring, tremendous amount of flooding, or in the case of Helene where they're putting out, the storm was going to drop 10, 15, 20 inches of rain, which we know causes catastrophic mudslides in these mountainous areas. That I think is what we really need to emphasize because you're going to have one number to kind of get at the intensity, but to get at the precip part, I think that, you kind of have to have that emphasized separately, which I think, in general, I think the public gets that the rain doesn't necessarily correlate directly to how strong the storm is. But I don't know.
Two quick announcements for our next speaker. Those that are going to be needing a ride to one of the airports need to get their return itinerary information to Tim, and his email address is tim.krgv.com. You get it to him, that'd be fine. Of our group photo will be at 1:15 today. Okay, moving on. Our next speaker, we're going to go back and look at the issues of storm surge, and Hal Needham, Dr. Hal Needham, has been with us for a number of years now. His area of scientific expertise is in storm surge, and we all affectionately call you Hurricane Hal, so take it away. You want this or the poster? Good.
And this is the clicker here. Black one? The black ones. I gotcha. Yeah. Okay. Hey, everyone. So there I was after Hurricane Milton in Southwest Florida, looking at 5 to 6 feet of sand that pushed in. In all my years of covering storm surge, I'd never seen anything like this. I could walk over to buildings and literally step onto the roof. At some points, my mind couldn't really comprehend what my eyes were seeing. This is one of the many surprises.